All right, so let's take a look at software development methodologies, a little bit of the history, where we've been, what has worked, what hasn't worked, and where we are right now. Okay. So yeah, so something easily explained. Right? It's a huge mess. All right, so the two large groups that participate in any project are the client, right, the one who is coming up with the money, that's coming up with the idea. What is it that they've identified a particular problem, and they come to you for help on how to solve this problem. And there's a tech side that we know how to build stuff, right? We might not know what to build, but we certainly, whatever you tell us, we'll build it for you. Okay. So for the client, they have certain knobs or certain things that they have control over, right? What is it that we want to build? What are the functionalities? What are the features? The time. I need certain things by a particular schedule. How much I'm willing to pay for this. Right, so I have a budget, I have some time, and I have certain things that won't need to be built. So these are the three things I typically control as a client, as the one who promotes this. And then on the tech side, we choose what the team is going to look like. I'm going to need some folks that know front end, some middle tier folks, some back end folks. I might choose a technology stack. I might choose the process in which we're going to manage this, the source control. So so each one has different knobs or set of controls that they have. Now working in teams, as we mentioned earlier, adds a level of complexity, right? It's very chaotic working in teams. It's messy. There's a lack, and we try to overcome that with lots and lots of communication, repeating ourselves over and over. Right? We should get into the habit of being comfortable with repeating ourselves, especially managers. Managers should be the most patient folks, and that's why they're managers, right? They find themselves repeating over and over, right? That please fill your timesheet, put your vacation in the vacation schedule. Lots of boring stuff, right? And they repeat themselves over and over what are the goals for this sprint? What are the goals for this quarter? What are the set of features? And developers are going to be asking them over and over the same dumb question, and the manager should be cool and just keep it, and just moving things forward. Making it easier for the developers. So we're going to need a fair amount of documentation, enough documentation for us to understand graphically what is it that we're going to be building. Not documentation per documentation say, right? We're going to document enough to be able to have a conversation that we agree with what it is that we're building, right? Older, more legacy approaches like the waterfall was really heavy on documentation. Right, we would not build anything until it was fully documented, right? And if a developer got something that was not well documented, they would complain and says, "How am I going to build this if it's not fully documented?" Right, that has changed today, and in the agile era, where we're fine with no documentation. It's the time for us to start conversing. Let's document this enough to understand that what we're building. So it's just-in-time documentation as opposed to documentation per se, right? As a tooling, hands-off of being able to, from one team give it out to some other team, which we'll practice in this course. Project influences, right? It's gonna be very, very complex. We need to be able to break it up. It's impossible to know everything, right? Even any one of us, there's no way that we can know everything. That collectively we might. But there's no one person that might know everything. Also, legacy, you're going to be most likely working with work that has been somebody else's code that you need to maintain and move it forward, maintain it while creating new features. And any development process is going to have to deal with certain key factors, right? Whether it's feasible, right? Can we even build this? Or are you asking me something so unrealistic that I'm not even going to bother? Can we specify? Can we have a formal specification of what it is that we're going to be building? The specification of what architecture we're going to be using, right? Of client server, Is this going to be rendered on the client, rendered on the server? What's going to be the development process? How are we going to be validating that we're making progress forward? And once this deploys, what are going to be the impacts of maintaining this going forward? Okay. All right, so let's look at some of the process model, the development process models that we have used over the years. So this was a one of the earlier models where we would build the first version and we just iterate over and over until the client said that they were satisfied. We would just get stuck in here until the client says thumbs up and we're done. We deploy and operate or retire when we're going to a new version or a substantial rework. It was there at the time there were no understanding of separation of concerns, right? That depending on what it is that you're building, you have different concerns. Right? For instance, in the front end, you have the concerns of how do I make this look pretty, right? What color schemes I'm going to be using? Human-computer interaction. There's a whole body of concerns of building front end, right? Whereas there's a completely different set of concerns of how are you going to store this in the database, right? The data model, whether it's going to be a very normalized data model, right, where you're going to have lots and lots of tables referencing each other, or it's going to be a very flat model. Right? How are you going to implement inheritance? How are you going to implement all sorts of things? Middle tier has a complete different set of concern, right? Being able to handle events that come from the client, mapping those to certain business rules that manipulate the model. So each one of the different aspects of what you're building has different set of concerns and different set of skills. Okay. Back then, there was not even a notion, right, that there were different concerns depending on what is they're building. Everybody was building everything. You wore different hats. You did everything, right? You did some UI, you did some back end, you deployed it, you did some maintenance, some admin, you did everything. There was no distinction. As projects became more and more larger and much more complex, folks realized that there are certain distinct activities that applications, when you're developing applications, that are very well defined. This is the first, one of the more successful models that became very, very popular in the 70s. Communication, planning, modeling, and this is just a joke. You can read it later. So some of the problems with waterfall. That projects rarely flow in a sequential manner. They're more like winding roads that have lots of ramifications. That it's very hard to know and explain every single requirement a priori until you actually are in the middle of it, right? Usually we don't think too much of how this is going to be maintained later on and how I'm going to deal with projects with bugs and updates later on. The customer doesn't see anything until the very end, right? They come in at the first time around. We interview them. We write down the requirements. We give it to them and says, "Is this what you want us to build?" And they say, "Yes, that's what I want you to build." We go off for a year. We come back with what we think is the implementation that they asked us to build. They look at it and it says, "Well, I know that's what I asked you to build, but I hate it." He says, "Well, what do you mean? This is exactly what you asked me to build." He says, "Well, I know that's what I asked you to build, but that's not what I want." He says, "Well, so all these blunders, right, are disasters. Lots of money, lots of time and effort went into building something that indeed was what was asked for, but that's not what they wanted." So we certainly we have identified this problem, and lots of folks have tried to solve this. Barry BoeHM'S is one of the folks that wrote lots and lots of theory on how to deal with this kinds of problem. He envisioned tackling this problem of the disparity between what was asked and what gets delivered. How is it that we can bring them together? That of congruence between what's asked and what's delivered. So he envisioned the spiral method where you have the same set of activities over and over, increasing by every time increasing in scope, right? In each step, you would have a identifying what the objectives were, developing and testing it, releasing it, reviewing it, and again doing over this. This is what he thought, and eventually he would expect that whatever end up being released is what actually is the client wanted. This was his envision in the 70s and 80s. He also had lots and lots of data that he managed tons and tons of projects, and he had a lot of data that explained what was the relationship of an error, of making a mistake, how expensive it was to make a mistake, depending on the different phases of a project. If you made a mistake, early on and was solved early on, then the expense and the cost was small. But the longer it took you to realize that error, that you had made a mistake, right? The longer that it takes to discover it and to fix it, the more expensive it gets, right? Obviously, the more you wait to fix that error, in unit testing or when system testing, or even if it's deployed in the field, that's the most expensive. If somebody's already using it, right, and you can't just change it on the fly. So an iterative approach was being presented, where the waterfall approach was now being broken into multiple phases or increments, where in each increment you would bite off or tackle a smaller chunk of the project, and you would iterate, applying the same 5 steps: communication, planning, modeling, construction, deployment, over and over. And at the end of each increment, you would deploy and make it available as an added value to the product. Right. So at each typically the first increment would be the minimum value minimum value product MVP, an MVP. Whereas what are the minimum set of features that would make it valuable for the client to even be useful? So that would be the first increment, and then each increment would then add a little bit of value to that first iteration. Another idea that became very popular is prototyping. That instead of going off and building something, let's prototype it. Right? Let's make a small version of what it is that we're going to build. Maybe put it in front of somebody's, give us some feedback, and then we can go off and actually build the real thing. Now, in prototyping, there's 2 types of prototyping. One is the horizontal prototype, where in each application, typically an application is going to be built on top of multiple layers, right? And on each layer, you can prototype a particular concept that you might not be familiar with, or you need some more experience on, right? So, for instance, you might be applying prototyping at the UI level, at the top level, and maybe building. The prototyping could be something just drawing something on a board, right? Or using maybe Photoshop or maybe even PowerPoint and making a mock version of some user interface. Yes, that it's not real, but at least it gives you something that you can put in front of the client. The client can click and see if they like it. If they like it, they can give you some feedback and says, well, what if we move this over here? What if we instead do this and that and the other? Right? So it's a throwaway prototype, but it gives you enough information that you can then go and actually build it. Okay? So this could be applied at any layer, right? Either at the top layer. Typically, it's mostly used at the UI, right? That's where it's most common, as opposed to the bottom layer. Or the other. So this is an example of just drawing some user interfaces. Or this vertical prototyping. Vertical prototyping is a throwaway prototype that allows you to test certain aspects, or maybe a certain new technology, maybe for the team, right? Or some technique or set of techniques that go across multiple layers, right? Maybe the front end, maybe going through the middle tier, maybe going to the business model, going down to the actual storage in the database, right? And you want to prototype something to see, how does it work? I've never used Spring. I've never used JPA. I've never used MySQL. I wonder how that works. And so you would create a little prototype. Kind of what we're doing, right? We created this little tiny hello world, right? And we see that we can access it. Next week maybe we'll add a dummy hello world user interface that goes and fetches data from the front end. And maybe we'll do another little prototype of storing some data, some hello objects in some database, right? And so that will create a hello world throwaway vertical prototyping that tests the front end, the middle tier, and the database. Yes? And it says, oh, I see how it works. Right? The front end sends an HTTP request, the middle tier receives it, and it executes this function, and then creates this object, and it stores it in the database. Right? And once we understand that, it says, now I can go and actually use this to build a real thing. Make sense? So all prototypes typically are meant to be thrown away. Okay? They're not meant to be part of the actual project. Okay? They should be enough to create some proof of concept, right, that gives you some sense of understanding, right, or some sense of confidence that you're actually going to be able to deliver what is being asked for. One of the things that we ask you is that typically you should resist the temptation, right, of creating a prototype that is so convincing or that looks almost like it's what you're going to be building that says, hey, why am I going to throw this away? Let's use it in the project. That's a bad practice, right? Oftentimes we have the prototype, we put it in front of the client, and the client says, "Oh, it's done." When it's really nothing, right? It's just some HTML pages that have some hard-coded stuff, right? And so we have to be careful, right? That the way we manage expectations for the end user. So all the processes as they have evolved over time have tried to copy or grab several of these techniques and put them together to grab some of the best draw from the best features of multiple of these processes, the unified process being one of them that grabs from the iterative process and the prototyping process and merges them together, creating what it's called a unified process, where you have, and it gives them different names, right? So we have the inception phase, we have the elaboration phase, the actual build of the constructing the application, and then some transition of being delivered and deployed and maintained. And there's different aspects of what you're doing of modeling, gathering requirements, but you apply all these across the multiple phases of the iterations. This goes to 315, is that right? Okay. So this explains each one of them. I'm going to skip over that. Agile. So Agile is kind of what we've been where the current where we currently industry is at, right? Where we're looking at we are accepting the fact, right, that developing software is chaotic, right? So how can we? What is the best way that we can adapt? So instead of trying to document everything at the beginning and try to make sure that things are stable and don't move. Instead, how can we adapt? We're going to accept change. We're going to accept chaos, right? We're just going to become very nimble. Okay. So it focuses a lot on certain aspects. So instead of focusing so much on documenting and making sure we have all the sequence diagrams and the class diagrams and the activity diagrams. Instead of focusing so much on documentation, we focus more on working software. The software is the document, right? It's self-explanatory, right? It should be self-documenting, right? It's so simple. Your function names are very well written. Your variable names are very well written. Your algorithm is so simple that just looking at it, it's obvious what's happening, right? I don't need to document this, hopefully. Also focuses a lot on the individual, how to interact, folks meeting, working together side by side, right? Collaborating on the same table and and just talking through this as opposed to going through processes and tools, right? Also, instead of making sure that the client is never going to change their mind, instead of focusing on negotiation and contracts, right, we focus on engaging the client becoming part of the process, right? We create something, we demo it at the end of the week, we get feedback immediately, and that becomes part of the process of the next iteration. So yeah, so different, a huge different focus on the process. All right, let's leave it here.